morning, and thank you, everyone. I'm Lisa Callahan, and I'll be moderating this panel today on the future of space and its impact on humanity. I'm just now realizing how long it is from me to the end of the panel here. So I'm honored to be the moderator for this panel this morning. We have some outstanding panelists that will be here with us today. I'll just briefly introduce them. So to my left, we have Sir Martin Sweetie. He's the executive chairman of Surrey Satellite Technology. And then next to him, we have Sandy Magnus, the executive director of the American Institute of Aeronautics and Astronautics. And then next to Sandy is Rick Tumlinson. He is the chairman of the Deep Space Industries and the founder of the New Worlds Institute. And then beyond Rick is Sarah Amiri. She's the deputy project manager of the science lead for the Emirates Mars mission, or the HOPE mission, with the Mohamed bin Rashid Space Center. And then all the way on the end, hi Minoo. We have Minoo Rathnasabapathy, who is the executive director of the Space Generation Advisory Council. Welcome, all of you, and thank you for participating today. We've heard over the last day a lot around investing in the next generation and investing in people to be the future of space. And at Lockheed Martin, we're very honored to have partnered with the UAE Space Agency in bringing in 16 early career folks, some of which may be in the audience today, and going through some space fundamentals. It was a 4-month intensive program where they came to the United States as well as within the UAE and learned about space programs from some of the experts that have been working in this industry for over 4 decades. And it culminated in watching of a launch of our OSIRIS-REx satellite that is on its way to a asteroid Bennu to return a capsule sample from that. We've also heard over the last several days that collaboration is significantly important to the future of space. And we're honored to be here in the UAE and hope to continue that collaboration. It's very exciting to see how far they've come in just a short period of time. But now I'd like to turn to the panel. And I'd ask each of you to just spend a minute or two introducing yourselves, and then talk about what the future of space really means to humanity from your perspective. So Martin, would you like to start?
Well, good morning, everybody. And this follows on very nicely from the panel we had yesterday, which was looking at the exploration of Moon and Mars, amongst other things. And I think it's quite clear that exploration in space is perhaps really the fundamental activity of humankind. Of course, we need to look back at Earth. We have a lot of issues and challenges on Earth and climate and other areas which we need to resolve, and that can be done from the high vantage point of space. But really, if we were to ask the most fundamental questions about humanity, it's when we look beyond Earth. We look beyond into the distant parts of the universe, and so space science, in understanding the origins and evolution of the universe, is quite central. But when we look closer to home, we have to think about the next steps for humanity in space beyond our planet. Now there are changes happening. This has been, space exploration has been the preserve primarily of the public sector since the beginning of the space age. But what we have seen in recent years is the growth of the private sector beyond just space applications to be taking an interest in space exploration. And so if we look into the future decades, I think we will see that there's going to be a partnership between the public sector and the private sector in order to increase the tempo of space exploration and to share the risks, share the burdens and the benefits. And this is going to be quite a different environment to that which we have seen in the recent years.
Thank you. Sandy?
Yeah, I'd like to add on to your comments in the sense that there's more and more people accessing space, whether it's government, emerging countries establishing programs or companies engaging in private enterprise. And I think it's sort of, we all get it. We all understand why this is important because we're the space community, and no matter where you live around the world, we're all very passionate about this topic, and we firmly believe this is where humanity needs to go. And I think what you see changing and what we can continue to work on together as a community is explaining to people outside of our community why space is so important and how space touches them every day. And that will only help the momentum go faster and faster as we get more and more people engaged in space as a planet. You know, when you look down on the planet from space, it's really amazingly beautiful, and it looks like, you know, Earth is our spaceship. And it was so obvious as I was looking out the window of the space station. You look down, and we're all on this spaceship together, and we're all ready to leave this spaceship together as one species. And it's just so obvious that, of course, we're going to work together. Of course, we're going to do this as humans, as our species. And so somehow we have to be able to take our innate understanding of how important space is and spread that into our external communities so that they understand as well, and they understand how space touches them every day. And I think that's still a communication problem that we're all struggling with no matter where we live. I know we still struggle with it in the United States. So I think that's really our next step in order to get further into space, is to spread that passion, and spread that enthusiasm, spread that relevancy to the communities around us.
Thanks, Sandy. Rick?
From my perspective, and I think perspective of the people I work with in what I consider to be sort of the revolution that's occurring right now in space, what we call new space, or what you see with the Elon Musks and the Jeff Bezoses and the Paul Allens, or my company, Deep Space Industries, which is looking at space resources, asteroid mining, is that without going into space, there is no future for humanity. That is I think the core belief of those people who are doing the kinds of activities that I'm engaged in right now. And it's fascinating for me to go to space conferences and events like this because I see in this community the birthplace, the traditional approach to space, which is the use of space to support different activities on Earth. And from that, from the work that's been done so far, standing on the shoulders of the giants that took us out in the original first period of space, those of us who are looking at space as a place to go and live, to go and be, are now being able to move from using space in terms of it being a place where programs are carried out, or we're using it like a telephone pole, that we're sending messages up and back through, studying ourselves from. We're able now to look at it as a place where future generations are going to go. And that's a little bit hard to grasp when you're in the existing industry or you're in the existing culture, because you're so used to doing what you do. But this is rising up underneath. And I would say 100, 150 years from now, when they're sitting in their conference on Mars or on the moon having a conversation, they're going to be looking at this period as the moment of transition. And I'm very excited by it. But it comes from the ability to create industrial economies, the ability to create partnerships, the ability to create enlightened regulations, policies, like we're just put together here in the UAE, or with our partners, Deep Space's partners in Luxembourg. So it's a moment of change, and I'm very excited about it.
Thank you. Sarah?
From my perspective, and I think across the conference over the yesterday and going on today, there's a lot of discussion with regards to the private sector and them entering and investing into space. And we are seeing a lot of money that's coming into space. But what's really important for it and to build sustainability, at least for space exploration for humanity, is for the space sector to build that business case and business model into our exploration efforts. It is very important that, and you mentioned it right now, which was, we know the exact value of space and we know exactly where space is being used in our daily lives. That is not communicated. I was in a conference about, an economics related to conference about 2 weeks ago. And they were talking about, they were using space data about ground, and they did not know that that data came from space, and the assets that basically guided a lot of their decision-making process came from space. And I asked a few of them, is space important? And the majority of the answer was no, it was not, when the majority of their judgment is there. That value proposition of why space is important is not something that the space sector, so everyone here included, has communicated very well to other sectors, and the links towards those sectors have not been there. If we're looking into having the private sector investment lift off the burden of space exploration, like you said, space exploration is very important for the future of humanity. The value proposition has to be built in today. Otherwise, we will see a sort of bubble that will burst, sort of 5 to 10 years of investment in space when the return is not there, because sustainability was not built into the model very early on. We will go back into having a lot of the funding and the burden of the funding to fall back on the public sector, and it cannot sustain it for very long.
Thank you. That's a very good point. Minoo?
Lisa, I want to draw on one word in your question, which was the benefits to humanity. And I think what we're going to see in the future is really these cross-cutting solutions that are being implemented now by space technology that are going to benefit and solve society's challenges and issues. And we see now, for example, with the increase in the number of constellations, which is providing ubiquitous connections. What is that going to do in 2030 or 2040? Things that we don't necessarily think about offhand. So, for example, it's going to increase literacy rates. So every person on this world is going to have a digital presence. So with that increase in literacy rate, it's going to also include empowerment of people, and how that's going to affect the world and how that's going to re-affect the space industry is something I think that needs to be addressed.
That's outstanding. Thank you very much. So we talked a little bit, Sir Martin, I think you brought up Mars, or exploration to Mars and the moon. There's been a lot of discussion lately about going back to the moon or to Mars with humans. What do you all see as some of the challenges to that?
Well, I think there are probably several challenges. Perhaps not least of all is finance. Going to the moon is not exactly a day trip, but it's a couple of days trip, I guess. But it's within reach. But if we go back to the Apollo era, we have just, I think, a flavor of how expensive it is, or how costly, not necessarily expensive, how costly it is. Going to the moon again and then moving on to Mars is likewise going to be a major investment, and this is going to require, I think, concerted effort, not just of the public and private sectors, but the international community. Because certainly sustained habitation in due course is rather like the International Space Station is going to be an international effort. But I think there's perhaps a wider question underneath all of this, if I could introduce that, and that is, I suspect that sometime in the next decade we will detect the presence of life forms somewhere else. Whether it be on Mars, whether it be somewhere in one of the other planets that we're observing in distant stars. And this is going to, I think, have a fundamental impact on how we view space and how we view space exploration. And it's perhaps debatable as to whether it's going to stimulate an outward look or cause us to become more introspective. I don't know. But it's certainly going to have an impact, I think, on exploration. And it's quite possible that this could catalyze humankind into coming together to put the necessary resources in order to expand our species beyond the surface of the Earth.
Thank you. Sandy, you mentioned we need to communicate to the world why space. So how would you describe why we might want to go back to the moon or to Mars, and again, some of the challenges?
You know, it's funny, and I'll just pull on NASA a little bit since I'm in the States. They have this very pretty chart, and I was talking about this at a conference last week. It's called The Journey to Mars. A lot of you have seen it, and it's got a picture of the Earth on one side of the chart, and then it's got the moon in the middle, and then it's got Mars on the other side. And then along the way it shows, ISS, it shows a launch vehicle, it shows a HAB, it shows some things, some equipment hanging out in cislunar space, and then of course some vehicles. So it's a chart about how to go to Mars. It's not a chart about why to go to Mars. And so you throw that out to the public, and they're like, yeah, okay, whatever. You know, they don't care about our toys as the way we care about our toys. And so you look at that, and it really comes down to space is the next frontier for human beings. It's that simple, right? And so we're going to go into space to spread humanity beyond Earth into the next frontier. And that's really the why. It's that simple. But that's very aspirational. It's very exciting. Then you have to go the next step. Okay, we're going to go, and what are we going to do there? And talk about what are we going to do there, and what are the outcomes that you're trying to get from that activity. And one of the outcomes is understanding how to live on Earth better. One of the outcomes is allowing more people to have, everyone to have access to space. And one of the outcomes is to establish these economies that aren't government-based in space. So I think talking about it that way, and as well as what are we going to do on Mars? And you and I, Lisa, were talking about this earlier. We talk about going to Mars, and inside our community, again, because we're all very passionate and we're all very educated on the subject, we talk about we're going to Mars, and we all understand that there's some context in going to Mars. We're going to go there and do some science, we're going to do some exploration, we're going to do some technology development. But what we talk about in the States, especially if we're off talking to the Hill or the executive branch about going to Mars, their paradigm is going to Mars the way we went to the moon, which means you go there and you plant a flag and you go away. And so that understanding of going to Mars to do X or do Y or do Z is not out in the external community, and we need to talk about that a little bit and talk about those kinds of activities and set up that rich tapestry that we all have internalized, and I think that will help. So that's the challenge of the communication is sort of getting outside of our own heads and trying to put ourselves in the places of people we're communicating with, and being aspirational and explaining in detail in sort of inspirational ways things that we're going to do, and not just talk about the how all the time and all of the equipment that we need to build. So it's just a little bit of a shift of perspective on how we talk about it.
I think as engineers, we're really good at explaining how we would get there. And not so
Oh, the
much
how is cool. The how is fun. That's why we all do this, right? But maybe not so much for everybody else.
Right. Rick, you have some ideas for why we might want to go to
A couple.
space?
I love what I'm hearing, and you're right. We are techno geeks, and we have a tendency to love to talk about the machines. You know, my rocket's bigger than yours, and we'll fly further and it's so cool, and this and that. The concept that is starting to shift, and you know, it's interesting. We do need to engage people that space is important, but we don't, at the same time, need to motivate everybody to get it done. One of the things we have a tendency to do in our community is to wring our hands to some degree and go, oh my God, the world doesn't understand me. I'm doing something really unusual and weird, and I need to sell it harder. When I first got involved in space, I testified in front of a commission, I'm dating myself, that was put on by our President Reagan. And my attitude was that we needed more astronauts on talk shows. And if we had more astronauts on talk shows, everything would change. I gradually shifted away from that understanding and began to realize, no, I have to make it happen. And I have to enable other people to make it happen. You see, when there's a real personal stake in it, everything shifts. One of the gentlemen in the last panel, I think from Bahrain, talked about raising the bar higher. This is the ultimate raising of the bar. We have a conference in Austin where we have 500 children, and they design their space colony. Now, I want to use, the language is very important. They're designing their space colony where they're going to live. And you walk into that room, and the glow and the fire that comes from them, the passion that comes from them, it's their house. They're not going out to support a bigger space program in their country. They're not going out to get more funding for space, or et cetera, et cetera, et cetera. They're building the house they're going to live in 25 years on Mars, on the moon. It changes everything to make it immediate. We don't have to win everybody. It's important to have a great discussion about the spin-offs and the fact that technology does this, and et cetera, et cetera. We often talk about the Apollo program in the US as having a lot of spin-offs. The biggest spin-off is me, or Jeff Bezos, or Elon Musk, or Space Generation, or all of the other organizations that came out from people who sat down and watched that. And by the way, we're watching Captain Kirk and Star Wars, and there's no accident that Elon's rocket is called the Falcon, Millennium Falcon. I mean, we took it on and we're doing it ourselves. If we can engender that in a generation and empower them that they can go, it changes. So to me, the biggest challenge is the psychology of what it is we're doing and why we're doing what we're doing and who we're messaging that to.
Sarah, can you talk from a UAE perspective? How do you speak in this country about why space exploration?
So why space exploration, and more specifically, why did the UAE go towards Mars? It's something that we've continuously spoken about. It's above and beyond the destination. And it's what you spoke about, Rick. It's about moving an entire generation towards exploration. It's building our capabilities in fundamental science and fundamentals and our capacity in fundamental science research, and providing opportunities to an entire generation in that area, which was not necessarily fostered previously here in the UAE. Another aspect of space exploration is the engineering. It pushes the boundary of human capabilities in terms of engineering and in terms of what our systems can do and what our systems evolve to be able to do for us here on Earth. It pushes technologies to a point where it's operating in a very harsh environment. It's operating very far away from Earth. And it's operating autonomously, and it has to be very robust and resilient to be able to do that. We also speak of exploration and the importance of exploration with regards to us as humans. It's not natural for us to live on a planet and just focus and learn about what the planet is internally from here, from what we observe, from what we see. If we did that, civilizations wouldn't have expanded beyond the realm of the walking distance that was around us. It is the same case when it comes to space. If we remained on our general understanding of what Earth is, we will never go beyond fundamentally understanding at the macro level where we are in the solar system. What does humanity really mean? What does our existence on this planet and this species really mean? And what is the science behind the development of the entire solar system? It's very important to study our neighbors, and Mars resembles Earth in so many ways than not. And it's very natural for us to strive towards understanding that planet and understanding other planets within the solar system, because it's really about understanding ourselves above and beyond anything else.
Thank you. Minoo, you're working with the next generation. Tell us about how you see that in the future.
So I want to build on what my other panelists have said. I mean, it's absolutely critical that we inspire the next generation, and you see, the UAE taking a forefront and really highlighting that aspect of things. But I think, as Rick was saying, we don't necessarily have to convince everybody. But when we talk about the next generation, we have to ensure that they're not just being inspired, but they're actively participating. Something I always say is that the next generation wants to be participants and not just spectators. So really, how do we get them involved, engaged, but how do we keep them in the space industry as well? How do we not lose them to other industries that are just as exciting? So you look at renewables, you look at mining, you look at energy sectors, they're also doing some incredible work. So how do we then utilize that or gain their interest and then keep them? And another point that Sandy mentioned is that we talk about going to Mars. We don't necessarily talk about what we're going to do there. So again, engaging other sectors, engaging young professionals and students in other sectors, making them, aware of what we do and how they can, how does a student who's studying climate change or resource management, how did they realize what they can do in the space industry is something, again, that we need to really engage on a much broader level than what we're doing currently.
That's great, thank you. So I recently had an opportunity to go to Seattle last week to go to the American Meteorologists Society, and one of the things that we were talking about there was really helping to put in perspective why do we need things like weather satellites and remote sensing and earth sensing devices. And a lot of it was, Sandy, as you put, we talked about it in terms of the science you know, the atmosphere and the stratosphere and this and that. And we said, well, how do you put that into language that people would understand? How do you correlate that to a farmer in Kansas that's worried about, you know, the moisture density in his soil and whether his plants are going to survive, or just weather events that would take place? So thank you guys for your comments. I think that's true. We need to really think about how we communicate this to industry or to the regular population and going forward. So can I shift gears a little bit and talk about technology in terms of, we've seen a lot more, in fact the last panel talked a lot about the development of CubeSats and how that's helping us to understand the technology and how to put technology into space. But we're also seeing the miniaturization of technology. How do you see that going forward in the future and its impact on humanity? I'm sorry, I'll start here.
Well, I mean, there's no doubt that the continued miniaturization, particularly of microelectronics, as we've seen over the last decade, has dramatically changed what we can do. The smartphone is perhaps the ubiquitous example of the ultimate in miniaturization and capability that we see today. I think over the last decade, 2 decades, we've seen the development of primarily ever-shrinking microelectronics. What we're seeing now is a change in more materials science and structures and the sort of mechanical and smart materials that go around it. And the combination of this, and as we have seen, the development of so-called 3D printing, additive manufacturing, and so forth, is going to have a significant impact in the coming years. If you think about it, building a satellite, you construct the satellite to survive the first 20 minutes of its life as it goes through the physically the most demanding part of its existence. Once it's in orbit, radiation apart, it's actually a rather benign environment. If we can take advantage of these new manufacturing techniques, we can not only end up with software-defined spacecraft, we can, I think, achieve in-orbit manufacturing, a digital factory in orbit, where essentially what we do is to launch, let's say, a lump of aluminium and a bag of sand on a rocket, and then we construct the structures which will house our spacecraft in orbit. And this will change, I think, quite dramatically how we can, what we can achieve in space. When you look at very tiny satellites, I think, again, we have to, on one hand, we are constrained by the laws of physics, aperture, power generation, how you transfer energy and data from spacecraft to Earth. But there are going to be a number of opportunities to carry out more scientific observations with perhaps either temporal or spatial resolution, which are easier than on the big spacecraft. So I think we're going to see a whole dynamic range of satellites, from tiny to large, but we're going to see a dramatic change in the way we actually build, launch, and operate them in orbit.
So Sandy, kind of taking off of that, do you see us going more to smaller satellites all over? Do you see a combination of the larger satellites, spacecraft, and smaller satellites?
No, I'm very much of a one-size-does-not-fit-all person. I think that you'll design your platforms based on the missions that you're trying to carry out, and we're entering this new world where there's thousands of CubeSats that need to go up there. Well, how are we going to manage them? How are we going to track them? How are we going to make sure they don't interfere with each other? Is there some aggregate of some missions where you maybe create a medium size? Or what are the roles of the large size? If you create a large satellite, that's very expensive. Are you going to be able to, we talked about servicing and reuse and repurposing earlier. So I think it's going to be a sort of a mixture of all these things. It's going to be driven by the technology. It's going to be driven by the missions. I think one of the great things about where technology is today is that the barriers and access to technology, because of the advancement of technology, is such that there are amazing things happening with access to space. I mean, the things that students are doing with CubeSats now in university would have been impossible when I was in school 30 years ago. And I think that's going to create some innovation. Is the baseline knowledge that the young people are coming into the sector with is absolutely spectacular. And it's going to be really interesting to see what they do with that knowledge and what they create with satellite systems. And it's going to be really hard to predict, but I think it's not going to be a one-size-fits-all solution regardless.
Great. So Rick, over time, I think we've seen where technologies that got us into space have been used back in other domains across, or other markets across the world. And now we're seeing technologies that are commercially available, helping us to leverage, get into space. How do you see that changing over time in the future?
It's interesting because there is a feedback loop between the space technology community and the private sector, and that's both human and technological. But I think one of the things, kind of the center of your question about all of this on this round, is that what we're seeing right now is we have more access, in that we're seeing more and more ability to go into space with the private sector, more openness in the public sector. We're having more capability in that the technologies that we have are so advanced, and they're shrinking in size. We've got our iPhones and things like that have immense capability. I mean, basically, CubeSats are cubic iPhones, in a sense, that we can send into space. And we have community in the sense that through the internet and the web and these types of things, people of different sorts, children, others, can participate real time in space activities in any place on the earth where they can get the internet or the web or a phone. And so all of that is creating this feedback loop in terms of the acceleration of what's possible, and who can be involved in it. So that's happening very, very, very fast. And I think the CubeSat, even though there's going to be many different kinds of spacecraft, the CubeSat, I think, in the future will be seen as the sort of the icon of low-cost standardization that kind of threw things open in a way. It's iconic. It doesn't mean that everything has to be done in a CubeSat or anything like that. But what it does show is that there's sort of a standardization occurring, and we have people like the private sector now that are allowing. If you look at space as a platform, when the people in Silicon Valley talk about a platform, my cell phone is a platform. What they're doing now by bringing the cost down is they're allowing us to access the platform of space. And through telecommunications and the internet and things like that, we're throwing that open so that people around the world, students in your countries, our country, can now apply apps onto that platform. So getting that first 100 miles allows us to get onto the platform, and now space is the platform within which all this creativity occurs. So it's really exciting for me, if that helps.
Sarah, where do you see technology in the future, and how that could impact space exploration, as well as how space exploration could impact technology here?
We're seeing a shift. So the CubeSats and the miniaturizations is actually, at least in my perspective, a byproduct of a change in the way we see space and in the way that we approach development of space systems. There is a move away from the development of space systems as legacy systems, and as systems that are additively built on experience and heritage moving forward because it works. And it's an indication that we do require, so this is sort of the other end of the spectrum of what we were saying here, that people don't know, the general public may not know the benefits of space, but we're seeing a large portion of the public that is understanding and requiring more data from space and relying more on space assets. And that is what the technological development right now will actually spin off. With the entrance of the private sector, investment of the private sector in space, because access to space is very expensive, there will be large innovations with regards to how would they benefit from space assets. Would it be the platforms that will go up there that would maximize the return of and I'm going to talk about weight, so a kilogram of mass that's sent to space, and maximize the return that's coming out of that, because at the end of the day, that is the largest expense that is incurred on any space asset that actually goes to space.
Great. Minoo, do you have thoughts on technology? And
Just to add again to what our panelists were saying, so I think with the miniaturization, as many people have mentioned, with the increase in autonomy, what we're going to see is the launch cost being driven down, which means that the term emerging space nation or non-spacefaring nation is not going to exist anymore. So every country is going to have space capabilities. Every country is going to want to have their own satellite. We see a lot of universities, sending their own CubeSats. So then it comes to another question of, how do we then not replicate what people are already doing just to say, I have a stake in space? So is it then a question of regional collaboration? Where does that take us? So yes, there's absolute technology innovation, which is critical, but how we use that technology is just as important.
And I'd like to actually add to that point. There's something very important that we're not touching on, which is a concept of democratization of space data, and utilizing to the maximum capability the current space assets that we have there. And there should be advancements with regards to utilizing the large amount of untapped data that is currently being captured, at least of Earth, and also of other planets, and of exploration. And that's an area where technological advancements can happen, and you don't really need space assets to do that.
so you all bring up a really good point. When all of the world has access to space, what does that mean? What are what will be happening from a collaboration point of view or a competition point of view? What are the pros and the challenges associated with that? Smart.
Well, I think what we're starting to see already is that terrestrial systems and space systems, which have been largely considered separate up to now, are starting to merge. And we will, if you combine ubiquitous 5G terrestrial communications, for example, with the constellations that are being proposed in low Earth orbit, geostationary overlays, fiber networks, the boundaries between space and terrestrial systems are going to merge. And if you add then into that mix the Internet of Things, not a very nice phrase, but Internet of Things nevertheless, and citizen science, almost ubiquitous sensors around the world which can be brought together to increase our information and data on the environment and other elements. I think we're going to see a completely different model for space, and combined with so-called big data techniques, this is going to, in the end, I think, provide a very, very different environment for what we now consider space and Earth. It will merge, and we will have a more uniform approach.
Interesting. Thanks. Sandy?
Yeah, I think actually Sarah is right on the money with her comment about the data. There's so much data already out there, and for those of you who go out and surf the internet, I go out to get on the internet and I'm almost stymied by where I should go look, because there's so much out there. It's overwhelming. And so that when everyone is connected to space, I think what that will translate into is people really being limited by their imagination and their creativity of how you dive into this sea of data and extract meaning from it in a way that's relevant to your community, or create a company that's relevant to interpreting that data for the rest of the world. I think that's really the key when you see everyone connected to space, is that it's really a creativity and an imagination challenge, and how to just manage all of the information that's going to be out there.
Rick?
I think we're going to be facing a combination of both fear and hope. When I say fear, what I mean by that is that the established guardians of nations and propriety, etc., don't know what to make of this. they're not going to know what to make of it when every country has the capability to put spacecraft in orbit above every other country and to do all kinds of things in space. Those barriers are going to lower, and so defense communities around the world are probably just going to freak out as this happens because they don't know what to do about it. Yet at the same time, what gives me a lot of hope is the generation that's coming up now, that's being raised, the new space generation that's occurring right now, has a different perspective about what it means to be a human being, what it means to be connected with people around the world. I think they have a much more benevolent and open cultural outlook and a way of working with each other collaboratively that just blows the minds of people who are trying to draw lines and say, this is a corporate domain, this is a government domain, this is our boundary, this is our, this kind of thing. I have a lot of hope, but I think we're going to have to come through this period where there's going to be some fear and there's going to be some reaction of, I mean, when we talk about mining asteroids, I have people who will occasionally say to me, well, you're going to drop them on the Earth, and then some of them with a sense of humor pick the favorite city they want me to drop them on, which sometimes happens to be the capital of my country. But anyway, I think that we are really looking at a time of real psychological transition, where participation will have to triumph over the sort of tribalism of the past, and space is going to allow us to do that.
Sarah, it looks like you have something you'd like to
I
add.
really like that analogy of the tribalism of the past. So space was very politicized for a very long time. And countries that have been in space for a very long people that have created access to space have used it as a political power, but we see that slowly transitioning, and like you said, the newer generation is, so our approach to privacy has changed. Our acceptance of more of our data being out there has changed. International collaboration is becoming more of a norm rather than becoming more of something to avoid, and something, like you said, to draw lines and more to influence in terms of what we can do and what we can't do. I speak of international collaboration, and I'll speak of it from the science perspective. Scientists don't understand boundaries with regards to political affiliation, geographic affiliation. There's no tribal system except a tribe of scientists, and the thirst of human exploration, and that will start overtaking the divisions that are currently happening the divisions that are slowly fading in space. I'll not speak, of course, to the cluttering of space. Space is not a limitless resource that is available out there, and international collaboration is key to better utilize the scarce resource that we have of the space around Earth, and that will see a large evolution over the next 20 years.
Minoo?
So what I love about the space industry at the moment, and something that everybody's talked about with the increase of participation, is this friendly competitive banter that happens between the private sector or government, industry, whatever it is, or just CEOs who just have a Twitter fight, and what people that gets people excited, and I think there's going to be a lot of innovation that comes out of that, because somebody wants to one up the other person, which is great. But something that Sarah said is about cluttering space, and really that's not something that we've addressed in this panel, is that with the increase in participation and countries sending CubeSats or picosats, whatever the case is, the issue of space debris is really significant. So this is another issue I think that we really need to prioritize, because if we don't get that solution solved, it's going to be hard for up-and-coming countries to really make their presence known, or for technology to even gain any further.
That's a good point. Sir Martin, did you have something you wanted to
Yeah, just 2 points occurred to me while we were talking. One is that, picking up on the points made about policy. policy always lags technology. But what we're seeing now is technology accelerating away from policy. And the policies that have been in place and have been gradually refined slowly over the recent decades, I think are very soon likely to break. And so we will see some dramatic thinking having to occur in the policy makers. And the other point that also occurs to me is, as we have this ubiquity of data coming from all these sources, both ground and space, and the ability to bring all this together, we've seen the phenomenon of fake news just recently. The question is, how are we going to validate this data? How are we going to protect ourselves against the data being used in certain ways to promote certain policies or certain thought processes and so on? And this is going to be a major challenge.
Yeah, you mentioned technology is, exploding and causing the policy issues. I think it's also just a number of entrants into this community. This used to be very government focused, right? And so government to government could work those issues and challenges. But now you have private sector and commercial industry, and where will that all go?
And if you just look at what happened in the communications industry, in the 60s, it was controlled very tightly, essentially through government-controlled organizations, and then through the evolution of the internet, all of that regulation essentially evaporated with the exception of a few key technical areas.
So we've talked a little bit about, a lot in this conference around the next generation engineers, scientists, getting the next generation excited about those things. It feels like it's more than just science that we need to get the next generation excited about when you talk about policy and economics and other things. What other areas do you think we need to be focused on with our next generation as we look to the future of space and what that could mean to humanity?
I'll let others carry on. I've had a few words.
I think getting them engaged in keeping them curious, right? Not educating the curiosity out of students, because the world that we live in right now, especially for young people, is you're going to be in a constant learning curve, a constant learning environment. And so having an educational system that inspires that curiosity, that sort of sets that as the norm, that you're always going to be questioning, you're always going to be learning, you're never going to be stagnant, and setting that mindset up for that kind of a thinking, that kind of a learning process, I think, is really important. And I'm pretty sure we have some challenges there in the States, because a lot of our learning is rote, memorization, you learn this, you learn that, instead of learning the process of learning. And I think that's what we can do for our young people the most, is give them that attitude and that kind of constant state of curiosity, and don't beat it out of them in the educational system.
That's great. Rick, anyone else have anything to add?
To add on to that, adaptability is very important. Jobs in the future, not in the future, jobs today are evolving faster than generations are entering into the job and leaving it. And adaptability of the future generation with regards to their skill set development, regardless of whether or not they're scientists, engineers, or people that are working in policy for space and not for space too. The lines are slowly being blurred across different fields, because we're no longer operating in silos, be it at a sector level and also at the level of professions. And the education system, like you said, needs to be completely changed for that aspect, where it focuses on the person's capabilities and development of their internal capabilities, rather than focusing on memorization and getting the maximum amount of knowledge there. It's more focusing on the ability to continuously learn and the ability to continuously acquire the right education.
I think we need to also acknowledge that the policies that we are currently putting in place is not going to be implemented by the people in this room. It's going to be implemented by the next generations. So really taking their opinions into consideration is absolutely critical. And what I would challenge people in the audience here is that if you're looking at a challenge, whether it be technical or policy driven, to really engage with your young professionals in your company or your organization to get their perspective. And I think what you'll tend to find is that these young people are really thinking outside of the box, which might send a shiver up your spines depending on who you are. But I really think that engaging them now means that the policies and the technology that we put in place are going to be like actually capable, people are going to be capable of implementing it in the future.
So I just wanted to thank you all. This has been a great discussion. I know I've learned a tremendous amount, and I think the future for space is so exciting. It does have its challenges, and I would ask you all to help us with those, but thank you so much. I appreciate your perspectives. Thanks.